Projectile is launched off a cliff that is 10 meters high. So this is a projectile which is 10 meters. I cannot really draw a freehand sketch. That's a 10-meter high cliff. It is launched at an angle of 30 degrees from the horizontal at some velocity v. And if it is supposed to hit the target, which is 25-meter away, so this landing point is 25 meters. So what is the initial launch velocity? So let's divide this complete analysis in two parts. So one is the vertical motion. In the vertical motion, we know that the displacement s is 10, the acceleration due to gravity is 9.8 meter per second square, that is also towards down, and the velocity, initial velocity is minus v sine of theta, sine of 30. Why minus? Because the initial velocity is upside and we are taking downward direction as positive. And this component will be v cosine of theta and the vertical component will be v sine of theta. So theta is what? 30 degrees, right? So let's use the third equation of motion, the second equation of motion, not in fact the second. Uh, I think, yeah, second equation of motion, that S is equal to V naught T plus half AT square. So we can get the time from here. So S is 10, initial velocity is negative V sine uh, negative v sine what do you call it as negative v sine 30 times t plus half 9.8 t square. So this can be written as negative, now 9.8 over 2 is 4.9, so this 4.9 t square minus v sine 30 is 1 over 2, so it's v over t minus 10 is equal to 0. Let's call it equation 1. And the same kind of analysis we can do towards the horizontal motion as well. So for the horizontal motion, the time of flight we already know. So we know that distance is speed times time, since there is no horizontal acceleration. So that will become speed, which is v cos 30 times the time. So from here, the time is coming as 25 over v cosine of 30. Let's call it equation 2. So what we are going to do is we'll substitute the value of t from here to here to get the value equation in terms of v only. So that's 4.9 times 25 over v cosine of 30 whole square minus v over 2 times 25 over v cosine of 30 minus 10 is equal to 0. So this v and v is cancelled. So I think it's a good idea to perhaps, let's rearrange this. So 4.9 times over v square times 25 over cosine of 30 whole square. Let's bring these two terms over to the right. So we are left with 25 over 2 cosine of 30 plus 10. I think that's where the calculator comes in. So let me just do that. This is, by the way, 30 degrees, just to avoid any confusion. Let me just grab my calculator. It's 25 over 2 over cosine of 30 plus 10 over 4.9 over 4.9 times cos 30 square over 25 square, 1 over this value, and the square root of this value comes out as uh, 12.93 meter per second up to 2 decimal places. Thank you.